Hello, this is Will White, Solar Application Specialist at Fluke. And in this video series, we are going to look through the user interface of the SMFT-1000. That's the Solar Multifunction tool. We're going to start with this video on the buttons and the dial on the front. First thing we need to know, the power button. The power button is the green button on the left-hand side. You push it once to turn the device on. You hold it in to turn the device off. Next to the power button is the brightness button. This changes the intensity of the brightness of the screen. It defaults to medium. You push it once and it will go to high. Push it again, it will go to low, and then medium is in the middle. The up and down arrows and the 4 function buttons, F1 through 4, are used to navigate through the screens of the device. We have our test button. Once we set up our instrument and are ready to go, hit the test button and it will run whichever test the dial is set to. Once we've completed the test, we can hit the save button. This will save the test into the device, which we can later download with the TrueTest software. The triangle with the exclamation point indicates voltage is present at the test leads. Anytime you have voltage over 30 volts, that little red triangle will light up. We also have the info button. Info button is extremely useful. Anytime you're set to any of the tests on the dial, if you hit the info button, a screen will come up that will show a graphic illustration of how to set the leads for the device up. Really useful, especially if you're new to the tool or to testing. On the right-hand side, we have the dial. We're going to use this to select the different tests. We start off with the menu. In the menu, we can access stored tests in the memory. We can change the client and site number. We can go into the device settings and we can go to the help screens, which are a list of all the info graphic screens. Next, we have a visual inspection. This follows IEC 62446-1. They have some specific requirements for visually inspecting a system before we start testing. So we can use that list to go through and do pass-fails for those tests to ensure that we don't miss any of the steps. R-low measures the resistance between 2 points. We use this to ensure that non-current carrying metal parts of the array are all bonded together. We next have voltage and polarity. We'll use that to ensure that the polarity of our PV string is correct. We can test open circuit voltage and short circuit current. We have the power and function test. In the power test, we'll use the voltage probes and the current clamp on the DC side to measure and calculate power. Then we can move the probes to the AC side of an inverter and calculate power on that side. And then the SMFT-1000 will tell us the inverter efficiency. Inside that test is also a function checklist. We use that for our inspection of all our equipment. We also have insulation resistance test. We can run that in a couple different ways. We have our IV curve test. We can do up to 1,000 volts and 20 amps per string of modules. We have bypass blocking diode testing and surge protection device testing. And then we have an auto function. The auto function is really handy because it will run multiple tests all at once. Once you hit the test button, it will run through the tests. If it passes the test, it will continue to the next test. If it fails the test or is outside the parameters that you set, it will ask you if you want to retake the test or skip on to the next test. Those are the basic buttons and dial features on the front of the SMFT-1000. The menu settings in the device. You can see that there's 4 things to select here. The first one is memory. This is where we can view any measurements that have been saved in the device. I have 14 saved measurements in here, so we can go ahead and take a look at those. I have some IV curve tests, some auto tests. These are all failed because I had some issues with the module manufacturer's data, so it's outside the 5% range for pass or fail that's set as a default in the device. In here you can view the measurements, so I can go in and view the measurements. An interesting thing with the IV curve trace, we can see nominal measurements. That is the manufacturer's data. Then I have the measured data converted to STC in the right column. If I hit the down button, it will also give me the actual measured data. We can see here that the irradiance meter was apparently not connected during this measurement, so it defaulted to 1,000 watts per meter square and 25 degrees C. We can see the table. We can also push the F2 button to go to the graph, and here we see the measured readings in the graph there. We did have our PV module set in, and it says the irradiance sensor was connected, but we don't have that irradiance measurement in there. In here, we can look at some measurements. I'm going to look at this IV curve measurement. So we just hit F1, the view button. It defaults right to the table. In the left-hand column, we have the nominal measurements, which are what the manufacturer's data provided. In the right-hand column, we have the measured data converted to standard test conditions. If you want to see the actual measured data, you just need to push the down arrow and it will add the measured data to the chart as well. We can see that this test was done at 735 watts per meter square, 26 degrees C, so just above standard test conditions for temperature and below standard test conditions for irradiance. Good way to look through and see how the test went. If we press the F2 button, we can toggle between the table and the graph. In the graph, the blue line is the STC readings, that is the measured data. The black line converted to what it would be if it was under standard test conditions. And that green bar in the middle is actually the plus minus 5% of the nominal readings. That's what we would expect from the manufacturer. We can go through and review other tests in here as well. I did some auto tests, so I can go in and take a look at those. It will show the pass-fail for the 3 tests that were done during the auto sequence. I can also press down to look through those individually and get the more details on those tests. The measurement data is in chronological order, so it starts with the newest measurement and goes to the oldest measurement, and we can go and view any of the ones that we want to look at in there. The next part in the menu is the client and site. This is really important to enter because it is what correlates the data in the SMFT-1000 to the client and site information in the true test software. If you add the correct client and site numbers into the SMFT-1000 before you start testing, it makes it very easy to download the data later. So I'll go in and enter this client and the site code. You can move to the left and the right using F1 and F2. You can hit done by hitting F3. You can cancel by hitting F4, and you can increase or decrease the number by hitting the arrow buttons. So I'm going to cancel here and go back to the main menu. Device settings are where we have all of our device settings. You can select the units. You can tell it how long the device will sit before it auto shuts off. I have it set at 20 minutes. It defaults to never, and you can do less than 20 minutes as well. We have our date time, important for knowing when we took the measurements. You can select your language. You can adjust how you want the device to beep. You can pair to your irradiance meter here. This is really important if you have multiple SMFT-1000s and happen to grab the wrong IRR2, which is our irradiance sensor, or if your irradiance sensor breaks and you have a different one and you want to repair it. Right now I have the IRR2 that came with the device paired to it. I could unpair that and pair another IRR2 if I needed to. I can check my firmware version. Currently I have the most up-to-date firmware. Calibration is for when you send it back to the factory and calibrate it. Reset file numbering is really important. This will delete all the stored measurements on the device. So if you go into reset file numbering and select that, hit reset there, F1, it will delete all the data you have on the SMFT-1000. So ensure that you download that data to the TrueTest software before you reset those file numberings. You can reset the device to factory defaults. You can go in and check what certificates the SMFT-1000 has if you need to show, say, an inspector that this is certified for use in a certain region, that's where you would find that information. And then finally, you have the licenses. The other thing in the menu screen is the help section. Here you have the same graphic diagrams that you have when you select the info button. So if I were going to do the auto test, I could go to the auto sequence, view that, and the device is going to show me how to set up my leads when I'm going to conduct that test. You can go in and look through this individually in the help section, or anytime you change the dial to a new test, if you hit the info button, you'll see this screen as well. So you can get it in both places. That's all the information contained in the menu of the SMFT-1000. We're going to review the visual inspection checklist in the SMFT-1000. So just switch the dial to visual. In visual inspection, you have two checklists. You have one based on IEC 62446-1 with 44 different items. The other one is a safety checklist with 20 different items. So go into this checklist, you just hit F1 to view the checklist. Each one of these items, you can give pass, fail, or not applicable. And you use F1 for pass, F2 for fail, F3 for not available, and then you can always go back. You can also hold any one of the pass, fail, or not applicable buttons for 2 seconds, and it will automatically fill out the entire checklist. So you can go through, there are different things that this checklist covers, and you can hit pass or fail or not applicable for any of these ones. This will allow you to complete the checklist, make sure you don't miss anything. And we go back and we can see, go down to the safety checklist, hit view there, same thing here as the last checklist. Pretty straightforward, nice way to ensure that you hit all the tests required by IEC 62446-1. We're going to go over the R-Low test in the Fluke SMFT-1000. This test is used to measure resistance between any 2 points in a solar array. We can test between, say, a module frame and our ground rod, or between different tables of modules in a large utility scale system. We have a couple of options here. One shot will test the measurement between the 2 points, and then it will reverse polarity of the test. We can also do individual tests, the positive or the negative. Now, an important thing to do before you do this test is to zero out your test leads. Connect the test leads together using the zero tool that comes with your SMFT-1000. Hit the zero button, it will run the test, and then it will tell you how much measurement there is there. Now, I have unlimited resistance here because I don't have any leads connected to this device. One thing to know, if you're using the 30-meter test reel, you may have resistance greater than 3 ohms. Unspool the reel will reduce that resistance so that you can zero out that lead. You can also set the limit for what's passing and what's failing by hitting the down button. I have this set for 0.5 ohm. That's the NIDA NTM. That's the ANSI NIDA maintenance testing standard limit for a passing resistance test for 2 pieces of non-current carrying metal parts bonded together. You can also go in and have the device set the limit. If I go down to set limit, I hit select. I can either manually put it in, or I can have the SMFT-1000 calculate the limit based on our length of cable. That's how long is between the 2 measurement points, what type of wire we're using, and the cable material, whether it's copper or aluminum. I think for here in the US, using a 0.5 ohms limit is a good one. And this is just going to set whether when you do the test, it's going to give you a pass or fail result. You'll still get the actual reading, but you'll get the red X if it's above the limit and the green check if it's below the limit. One other thing in here, when you go into the test, You set the limit. I have this, let me go back. I have this set for equipment bonding. I can also go in and change it to lightning protection as well if I'm doing a test on a lightning protection system. That is all the features within the resistance test. If you have any questions, please reach out to our technical support. We're happy to answer them. Let's take a look at the voltage and polarity test of the SMFT-1000. This is extremely simple. The device is just going to check to ensure that the positive lead from the meter is connected to the positive of the PV string, and the negative lead from the meter is connected to the negative of the PV string, and it's going to give you a voltage. If we go in and hit info, it's going to tell us how to set the device up. Very simple. Red lead goes to positive, blue lead goes to negative. If this was hooked up to a module or a string of modules, we'd already be seeing the voltage and polarity. So very straightforward way to check and ensure that your string is actually wired properly and that what you think is the positive conductor is actually the positive and what you think is the negative is actually a negative. This is a good way to test voltage as well. We can test up to 1000 volts DC using the SMFT-1000. We're going to look at the open circuit voltage short circuit current test of the SMFT-1000. Here we can see the screen that we get when we switch to the VOC-ISC test. If this were hooked up to a module or a string of modules, we'd be seeing the open circuit voltage here. If we had the short circuit current, we could run that as well. We would need to hit the test button to see the short circuit current. We can also test operating current and operating voltage. If you have the Pro kit, you got the Y MC4 leads. They have a positive lead on one side, negative lead on the other, and then the test lead coming off as the Y there. We can also use the current clamp to measure operating current. In this, we can select our PV module. You can load modules into the SMFT-1000 using the True Test software. You hit the down arrow to see previously used modules. I have about 6 modules loaded into the SMFT-1000. You can load up to 24 modules at a time. You can also connect to your IRR2 meter. I have the IRR2 here off screen. I'm inside, so I have no irradiance, but we can see the ambient temperature in the room. We also get the tilt angle there too. So if I move the sensor, you can see the tilt angle is increasing there. If I had the external sensor connected, it would say external right there as well. So this is a pretty straightforward way to measure open circuit voltage, short circuit current, or operating voltage and operating current with the SMFT-1000. We're going to look at the function and power tests in the SMFT-1000. This is the screen you see when you first switch to that test. We have the power measurement here. This is set for a split phase power measurement. What we do is we can go to the info button and see how to set this up. We connect the voltage probes and the current clamp on the DC side. We'll take a measurement there, and then we will move to the AC side and measure the current and voltage there. And the SMFT-1000 will compare the two and give you the inverter efficiency. In this screen, what we'll do is we hook our probes up, and then we'll hit the test button. We would see voltage and current come up there, and then we would hit the F3 hold button, and that's going to hold the DC measurement. We're going to move our probes to the AC side. We'll hit the test button again, and then our AC volts and AC current will come up, and it will calculate power on both sides. And then right where it says measure DC side, it would give you the inverter efficiency. If we hit the up arrow, we can use this to test a 3-phase system. And again, going to the info button is going to show us how to set that up. The DC side is the same. When we go to the AC side, we're going to put the red lead on L1 and then the blue lead on the neutral and our current clamp on L1. AC output of inverters, the voltage and the current on each of the legs should be the same, which is how we can calculate the 3-phase power. Everything else is going to be the same on here. We can switch back to single phase. Another thing that we can do here is we can set our limit. If I push the down arrow, this is going to say whether the rating of the efficiency is a pass or fail. That's it. Most modern inverters are in above 90% efficiency. Some off-grid inverters are going to be less than that, so you can set that. And again, it simply affects whether you're going to get a pass or a fail on the in the device and on the True Test software. The other thing we can do in this screen is go to voltage and current. And anytime you see small options next to a function button, that means you can push the function button to toggle between the two. So if I push it once, it's going to go to voltage. This will give me the live voltage reading of my probes on whatever I'm testing. Obviously, I don't have anything hooked up right now, so it's seeing 0 volts. If I hit the F2 button again, it will give me the current reading from my clamp. Now, the thing you need to do with the current clamp that comes with the SMFT, first off, make sure you turn it on. I've made that mistake before, so turn the clamp on, go to this current setting and use the dial on the current clamp to zero that clamp out. Obviously, I don't have a current clamp hooked up. It's not zeroed, so I'm getting a false reading here. Then I can go back to power and I can rerun my test using the test button, knowing that I have zeroed out my current clamp. That's important to do before conducting the test. So great way to measure inverter efficiency and to see our voltage and current on both the DC side and the AC side. We're going to look at the insulation resistance test feature of the SMFT-1000. This device is a little unique compared to other insulation resistance testers in that it's designed to be used specifically with solar modules and strings of solar modules. The default insulation resistance test is this insulation resistance test 2. And what the device is going to do in this test is it's going to short circuit the positive and negative of the PV module or string together, and then it's going to test the resistance of that short-circuited string to ground. Really unique feature with the SMFT-1000 that you won't see in other standard insulation resistance testers. Insulation resistance test 1 is more of a standard insulation resistance test, and what it's going to do is it's going to measure from positive to ground and then negative to ground, and it's going to pick the highest value and give you the results for that. We also have a continuous insulation resistance test. This is a point-to-point insulation resistance test like you would see with any standard insulation resistance tester. That's going to allow us to measure things like our PV output circuits from our combiner box to our inverter when they're disconnected from PV modules. We also have the wet insulation resistance test. This is actually test 2, where it short circuits the positive and the negative together and then tests to ground. What we're doing here is indicating that this test was done under wet conditions. That could be in the morning when there's moisture on the array, it could be on a rainy day, or we could have used a hose or other device to wet the array down. When we have wet array, we're going to have less resistance to ground, a good way to find intermittent ground faults. Also in this screen, I'm going to go back to the standard test. I can use the down arrow to set the voltage. I have a couple different voltage levels I can do the insulation resistance test at. This is set to 1000 volts, which is the highest voltage. I can also do 500, 250, 150. That's the lowest setting. So usually if we're doing normal PV arrays, we're doing a 1000 volt test. The other thing we can do is set the limit. That was actually back in that screen. The limit changes depending on which test you're conducting, and that's based on the IEC 62446-1 standard. So as I change the voltage, the minimum resistance is going to change as well. So this is a great way to test our modules, test either individual modules, strings of modules. We can do point-to-point resistance testing. The SMFT-1000 comes with a probe tip that has a test button right on it. So you don't even need to hit this test button. You can use the one, the probe tip. It's a great way to conduct that test. We're going to look at the IV curve test menus in the SMFT-1000. When you first go to IV curve, the first thing you're going to see is this table. This will give you the nominal value, that's the manufacturer's data from the module manufacturer, and then STC is our measured value converted to what the module would be doing under standard test conditions. In this screen, we can also push the down arrow and set our passing criteria limit. It defaults to 5%, which is the IEC 62446-1 standard for IV curve tracing modules. And if you change this up or down, that's just going to impact whether a result is a passing result or a failing result. You'll still get the actual numbers, but this is what affects the red X's and green checks. I can go back. I can also see data in a graph form. As you're doing IV curve testing, you'll actually see the IV curve populate as the test is being conducted. In this screen, we can enter the PV module. We can do it in a couple different ways. We can manually enter the module data using data off the spec sheet or off the module label, or we can use the TrueTest software's module database to input the information automatically. I've already uploaded some module data, so if I hit the down arrow, I'll see all the modules that have been loaded into the SMFT-1000. Right now, I've got 6 different modules loaded into the device. You can load up to 24 modules at any one time. I can also add new. That's where I would go in and create the module based on the information that I have in the field. I can use the F1 button to select the module. I can also delete all the modules out of the SMFT-1000 if I wanted to clear the memory as well. I can also pair the device with the IRR2 meter. It actually needs to be paired in the menu in the settings menu, but I've already paired an IRR2 here, so off screen I'm going to go ahead and turn that on. It's going to sync with my SMFT-1000. You can see it's synchronized now. I'm inside, so I'm not getting any irradiance, but you can see the ambient temperature around 21 degrees C, and the tilt angle. I can lift my IRR2 up, and the tilt angle will change in pretty much real time. I'm using the internal sensor. I could use the external sensor as well, and that would be reported to the SMFT-1000. When I go back to the table at the top, you'll see my readings from the IRR2, both irradiance and temperature in real time. Once I'm ready to create a test, and I would want to select a PV module first. I didn't do that previously, so I'm going to select a module, and I'm just going to take the one at the top of the list. I'm going to tell it how many modules I have in the string and how many in parallel. The SMFT-1000 can measure up to 1,000 volts, so that would be the number of modules in a string, and it can measure up to 20 amps, so that would be number in parallel. So I can go up and just tell it how many modules I have in series and parallel. You actually hit the F1 and F2 buttons there to increase or decrease that number. So once I have that entered in, you can see the PV module is now checked. My IRR meter is connected, and I am ready to test. I can go back to the graph, and once I hit test, it will start populating the graph. Now you can see this kind of bluish green area here. That is plus or minus 5% of the nominal expected result. So that's the manufacturer's data plus or minus 5%. When you do the IV curve trace and go back and look at it in the menu of the measurement settings, you'll see a black curve on there. That's the measured curve. And then you'll see a blue curve. That's the STC curve. That's the measured data corrected to standard test conditions. And hopefully it will be within that blue-green box there. That's the basics of IV curve testing, the interface with the SMFT-1000. We're going to look at the diode and surge protection device tests in the SMFT-1000. When you first switch to this test, the first thing you'll see is the bypass diode test. In this one, we can test bypass diodes to ensure that they're meeting their manufacturer's ratings. We can hit the down arrow and set the voltage limit. We're going to need to know the data from the bypass diode manufacturer or the PV module. In some cases, you may be able to get the module data from the mobile app, which is currently in development, but in most cases, we're going to go down and set it manually. So we can go in and manually set what voltage should pass through that bypass diode. Something to know about testing bypass diodes with the SMFT-1000, you have to black out the module in order to do the test. The voltage that the PV cells are creating will interfere with the bypass diode test. So you need to somehow cover the module or do it at night when there's no irradiance. We can also test blocking diodes, very similar to the bypass diode test. You need to get the manufacturer's information for what voltage should be going through that diode. We can also do a continuous diode test. If we had lots of diodes to test, we would use this one where we can just go point to point and test those diodes. We can also test our surge protection devices to ensure that they're working properly. Again, we want to go and find the manufacturer's data of the surge protection device and see what the voltage through that surge protection device should be. We can hit the info button and see how we're going to set up our leads when we do that test as well. So handy thing if you're doing bypass diode testing in the field or you want to test your surge protection device. We're going to go through the auto test sequence of the SMFT-1000. This is a great test to do if you want to conduct multiple tests at once without having to switch the dial between the different tests and without having to move things around. First thing, we can hit the info button. It's going to tell us how to set up the device. We hook the red to the positive of the PV module or string, the blue to the negative side, green goes to the ground, and the yellow goes to some metal point that we want to test. So a great way to do several tests all at once. You can use the 30-meter spool for the green wire in order to test the modules. Oftentimes, I'll put that green wire on the grounding bus bar in, say, an inverter or a combiner box, and I'll use the yellow one to go to the module frame to test between the two. You can also use that 30-meter green spool on the yellow side as well. Okay, going back to the main test, the first thing we need to do is set up the test and decide what tests we want to conduct. So we're going to hit F4 to hit test setup. First is the sequence type. So I can go into here and select what tests I'm going to do in this sequence. The first one is, do I want to do an insulation resistance test or not? And that's going to be that type 2 insulation resistance test where it short circuits the positive and the negative together and then tests to ground from there. I can go down and select the category. Category 1 is going to give me the ground bond test, so that's that R-low test where it's testing the resistance between 2 points. Category 2 will give you the R-low test and an IV curve test. That's the performance part of safety and performance. Now, going down to the protection class, in the United States, we're always going to be protection class 1. That's for systems where the non-current carrying metal parts are bonded to ground. So our module frames, our racking are all bonded to ground in the United States. In other countries, they may have protection class 2 where the non-current carrying metal parts are not bonded to ground, but we won't see that here in the United States. So once we go through and select these, we can go back. The next thing we need to do is select our PV module type. I've already selected a module type, but I can go in here and I can edit my module info, or I can select a different module. I have about 6 different modules already uploaded into the SMFT-1000 from the True Test software. I strongly suggest uploading module data before you get out in the field because it's much easier than going in and manually entering it into the SMFT-1000. We can also select the number of modules that are in a series string and the number of strings in parallel. The other thing that we need to do here is connect our irradiance meter. Mine is not connected. If I select that and I turn my irradiance meter on, it's going to pair with the irradiance meter, and I've got it connected now. I'm inside, so no irradiance, but I do have the temperature, the tilt angle, and I'm using the internal temperature sensor there. So now I can go back. Once I have all this information in, I can also set the information, since I have set this to do the insulation resistance test, I can select the voltage that test is going to be at. In most cases, we're usually going to do 1,000 volts unless you're testing a single module. We can also set the resistance limit. I have this set to the ANSI NITA 0.5 ohm setting that's in their maintenance testing standards. You can also go down and see the testing diagram, which you can also see by selecting the info button. Here it gives you a little bit more information than we get from info, but it's pretty straightforward. That's the end of all the options. Once we have the auto test sequence set up, we'll go back to the main page. Then we'll just set all of our stuff up, hit the test button. It will run through the sequence automatically. If a test is passing based on the criteria that we've put into the SMFT-1000, it will automatically move to the next test. If it does not pass based on that criteria, it will ask the user if you want to rerun the test or if you want to move on to the next test. So if you have passing results, it'll just go through each of the tests and automatically run them. Once you're done, you will hit the save button. You'll tell it where in the array you're at, what electrical panel, which inverter, which combiner box, which string, or even down to which module you're testing. Important to put that data in because once you're done, when you download the information to the TrueTest software, it helps to have that already configured in the SMFT-1000. That's the end of the auto test. Thanks for joining me.